In this video, I want to go over the Euclidean algorithm for finding the greatest common divisor of two positive integers. And the Euclidean algorithm is based on division with remainder. So let's review division with remainder. Suppose that you have two positive integers with a greater than or equal to b. Then there are unique integers q and r such that a is equal to b times q plus r, with r between 0 and b. And r is strictly less than b. So this is a strict inequality. Okay. So hopefully this fact is familiar. So the question based on this is, how are so here's the question. How are the divisors of a and b, so these are the common divisors, related to the common divisors of b and r? Well, let's think about this. Suppose that d is a common divisor of a and b. Well, if d is a divisor of a and b, so a and b are multiples of d, well, r, so if you look at this equation, r is equal to a minus bq. So if d is a divisor of a and it's a divisor of b, then d is also a divisor of b times q. So d is a divisor of a and bq, and therefore it must be a divisor of r, right? Because if you have, a multiple of d minus another multiple of d, what you get is a multiple of d. So if d is a common divisor of a and b, then d is also a common divisor of b and r, because d is a divisor of b, okay, by hypothesis, and we showed that d is also a divisor of r. And conversely, if you are given d, but now you know that d is just, if d is a common divisor of b and r, then d is a common divisor of a and b. Because if d is a divisor of b and r, well, then d is a divisor of bq and r, and so bq and r are multiples of d, and when you add two multiples of d, you get a multiple of d. And a, therefore, must be a multiple of d. So what did we show? We showed that if you have a common divisor of A and B, it must be a common divisor of B and R. And if you start off with a divisor of B and R, then it is a common divisor of A and B. So if you put those together, that means the divisors of A and B are the same as the divisors of B and R. In particular, the greatest common divisor of A and B is equal to the greatest common divisor. Why is it doing this? It's so annoying. Of B and R. Okay. Let's put this in the box because it's important. I just want to make sure. Yeah. Okay. And it's this fact that we're going to use. To find the greatest common divisor of two integers, because what's going on is that you start off with the GCD of A and B, so this is the thing that you're looking for, and then once you do division with remainder, you get that this number that you're looking for, the GCD of A and B, is equal to the GCD of B and R. Well, B and R, R is less than B, so you end up with two smaller numbers to find the GCD of. And you can repeat the process, and the numbers get smaller and smaller and smaller until one of them is equal to 0. Okay. Like in, meaning that eventually you get a remainder of 0, where one is a multiple of the other. Okay, let's just do an example just to illustrate this. So find the greatest common divisor of 2024 and 748. So we use division with remainder. 2024 turns out to be 748 times 2 plus 528. Okay. So just to be clear, let's call this our A and let's call this our B. So this 2 would be our Q and that's our R, right? So what we found above, I'm just going to do this on the side, is that this thing we're looking for, the GCD of 2024 and 748, is equal to the GCD of B, 748, and R, which is 528. So now we do division with remainder again. 748 is equal to 528 times 1 plus 220. Right, so our new A is 748 and our new B is 528 and our new Q is 1 and our new R is 220. So this GCD that we're looking for is the same as the GCD of 528 and 220. Now we write 528 is 220 times 2 plus 88. So continuing what we found above, this GCD we're looking for is equal to the GCD of 220 and 88. And we continue, 220 is 88 times 2 plus 44. So the GCD we're looking for is the GCD of 88 and 44. And hopefully we see what the answer is, right? 88 is 44 times 2 plus 0. So finally we get a remainder of 0. This GCD of 88 and 44 is therefore equal to 44. I mean, if you wanted to, this is sort of an extra step. It would be the GCD of 44 and 0. Now, 44 is a divisor of 0 because 0 is 44 times 0. Right? So 0 is divisible by 44. And 44 is divisible by 44, and therefore 44 is the greatest common divisor of 44 and 0. So the GCD that we were looking for, the GCD of 2024 and 748, is 44. So that's how you find the greatest common divisor of two positive integers using the Euclidean algorithm. I mean, the Euclidean algorithm, all it really is, what we did was the Euclidean algorithm. All it is repeated division with remainder. The key thing to keep in mind is, what's your B and the R, right? So, just keeping it straight that once you have this, the numbers you use to continue are going to be the B, so one of your numbers from A and B, the smaller of the two, and then the remainder. And you don't use the 2, which is the Q. Okay, thanks.